All right, welcome to video 9. We're into substitution. So in this case, we're dividing a right triangle into many equal areas. You can see that this one's 1/2 the base times the height is 100. So we're going to solve for the missing sides for each triangle that subdivides that into equal areas, 3 equal areas. Let's zoom out and show you this is where we're at. We've got one more to do. This is going to be unequal areas, and then this one will be it's just an example of 2 adjacent triangles with an area. Given the angles, what's the missing sides, and then the subdivision stuff. So let's go take a look at the solution for this one. We have here's our problem. I'm calling it the parallel offset method because there's really, I don't know what the name would be, but it's just telling us that it's parallel to this one is how it's getting subdivided. We know that each one's a right triangle. So let's get into the solution. It shows us the steps. So it looks like a lot of steps, but only because I'm showing everything. So 1/2 the base times the height. 100 divided by 3 is 33.33 in each one. I'm going to take second one would be 66.66. What we use is we could use the actual decimal value. It would get really hard to keep track of what it is, so we call it the tangent. So the arctangent of 10 divided by 20 is 26.5651. So the tangent of the angle is what tells us what that decimal value is going to be. So we're going to do the same thing we did before. We're going to we're going to find out what's the value of y, and y is equal to the tangent of 26.5651 is y over x. We're going to substitute y with tangent of 26.5651 times x, right? Like we did before. So that is what y equals. Skipping a step. Tangent of 26.5651 is equal to y over x. And we're going to solve for y, so we just move x to the other side. And that's what we get here, y is equal to this times x. So we're going to plug that into the formula. 1/2 of y, which is 26.5651 times x. So we did that here, 1/2 of tangent of 26.5651 times x times x. So we just replace the y with this value. All right. We did that in the last video. I'm explaining it again and again, but and that just breaks down to times x, so x squared. So now we have 1/2 tangent of 26.5651 times x squared equals 33.33. So we're going to multiply both sides by 2 to get rid of that, and divide both sides by tangent of 26.5651, and we end up with x squared is equal to that, right? Then we're going to square root both sides, we end up with x. So now that we've solved for x, x1 is equal to 11.5464. And we've done that there. And then to solve for y, we already know that it's tangent of 26.5651 times x. So tangent of 26.5651 times 11.55 will equal 5.7735. And that's the dimension that we've got right there. That's how you solve for that. Check your answer, make sure that this times this, 11.55 times 5.77 is equal to 33.33. And then once you've done that, you just take the actual formula for solving for x. Doesn't change much, it's just the area, right? So the x squared 2 tangent of all this stays the same except for the area. So you can just plug in the same formula, square root of 66. And then in the last case, to do the same thing, you just multiply the tangent of 26.5651 times the result, and you'll end up with the value 8.165. Check them again, multiply, and make sure that they're coming close enough to your value with the decimal places. let's go to, I already did this, but it's the second time I've done this video. So take this, we're going to take it and paste it into Excel. Probably not going to paste it into Excel. Would be, maybe, let's see, Control B. Not sure, A, B, A1, B1, C1. So we could actually use that right here. 30 degrees, let's call it just a random number, 30 degrees, 35 minutes, 22 seconds, right? If you had, yeah, so there you go. Let's take that, change those values to 1 decimal place. No decimal place, right? Just a whole number. Then in here, we're going to say it's equal to 31 plus B2 divided by 60, because there's 60 minutes in each degree, plus 22 divided by 3600, because there's 3600 seconds in a degree, and that's our answer. That's it, gives you the decimal place. When you're using this, if you're going to take that information and use it somewhere else, you want to make sure you pull those decimal places up to whatever the value is that you need, and that's how you get degree minute, the decimal degrees from degrees, minutes, and seconds. In case I didn't mention that. Yeah, to DMS to DD. So that's how you do it. They've got the Construction Master Pro does that. I'm not sure of the Construction Master Pro for sure. The Construction Master Pro, if you're going to get one, spend the money and get the Construction Master Pro, because it does a lot of other stuff that you can use in construction. And that's one of them. I don't think the others do it. If you're on an instrument that's showing this stuff in DMS, you want to be able to convert it to DD. You can do that pretty easy with the Construction Master Pro, or you can do it in Excel. Or you can get an instrument that shows both. Let's go to the next one. Is going to be subdividing right triangle with unequal areas. Given, let's say the whole area here is 100 squared, and this one's 135 squared, and you have the angle. I'm going to show you how to calculate those. And it's exactly the same. It's just kind of worth mentioning that, oh, you know what, I think I did. Yeah, I did. So I showed you how these scale out, this relative to this, how the area changes exponentially to the distance. So maybe I'll do a video on those, maybe not. I just don't use that method. So I know there are people out there that'll explain it, but I didn't see any videos on it to get it. So anyways, we'll see you on video 10.